Hello everyone. Today we will going to see some practice questions from the topic chemical kinetics, and this is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is the index slides. Today we will going to see the practice questions from question number 9 to question number 15. Let's start with the question number 9. The rate constant for a zero order reaction is. Options are K is equals to C naught by 2T, K is equals to C naught minus Ct divided by T, K is equals to ln C naught minus Ct divided by T, or K is equals to C naught by Ct. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option B, that is K is equals to C naught minus Ct by T. So for a zero order reaction, this will be the rate equation for the reaction. So minus of dA by dt is equals to K times A to the power 0. Concentration of A to the power 0. So it will become 1. So dA will become equal to minus K dt, and we just integrate both sides with the proper limits. So dA is the concentration, so we integrate it from A naught to the A at T is equals to minus K times integration. K is constant, so it will come out of the integration, and integration of dt is from 0 to T. So dA will become C naught minus Ct, that is initial concentration minus final concentration at T time, divided by the dt integration will be T minus 0, that is T. So divided by T, and this is coming out as K value. Okay. So rate constant for a zero order reaction will be equal to this equation, and thus our B option is the correct answer. Question number 10. The rate for decomposition of ammonia on platinum surface is zero order. What are the rate of production of N2 and H2 respectively? If K, that is rate constant, is equals to 2.5 times 10 to the power minus 4 mole per liter per second. Options are 1.5 times 10 to the power minus 4 mole liter inverse second inverse, and 3.5 times 10 to the power minus 4 mole liter inverse second inverse, 3.75 times 10 to the power minus 4 mole per liter per second, or 1.25 times 10 to the power minus 4 mole per liter per second, 2.5 times 10 to the power minus 4 mole per liter per second, or 7.5 times 10 to the power minus 4 mole per liter per second, or 1.25 times 10 to the power minus 4 mole per liter per second, and 2.5 times 10 to the power minus 4 mole per liter per second. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C. So this will be the reaction, right? 2NH3 giving us N2 plus 3H2. If you write the rate equation for this reaction, it will be minus half the change of concentration of reactants divided by dt. It is also equal to change of concentration of products. So d of N2 divided by dt is equals to 1 by 3. Stoichiometric coefficient will come in the denominator. So 1 by 3 d of H2 divided by dt. Okay, so these three are equals. Now, as we have given that the decomposition rate of NH3 on the platinum surface is zero order. So the reaction is zero order. And for the zero order reaction, rate equation is equals to K times the concentration of the reactant times power 0. Right? In the zero order, the reactant concentration power will become 0. So rate will become equal to K. That is rate constant. That means we can say that rate is also equal to this one. Right? So we can write that minus of half d of NH3 divided by dt is equals to K, because rate is also equal to K, rate is also equal to this. So we can equate both these. K is given as 2.5 times 10 to the power minus 4 mole per liter per second, right? Or you can also say that d of N2 by dt, d of N2 by dt is equals to rate, and rate is equals to K. So d of N2 by dt is equals to K. Similarly, 1 by 3 d of H2 by dt is equals to rate. So 1 by 3 d of H2 by dt is equals to K, and 3 will comes in the multiplication. So d of H2 by dt will become equal to 3 times 2.5 times 10 to the power minus 4, which is 7.5 times 10 to the power minus 4 mole per liter per second. Okay, so this only we have to find out, that the rate of production of N2 and H2. So it will be 2.5 times 10 to the power minus 4 and 7.5 times 10 to the power minus 4 mole per liter per second respectively. Thus, the C option is the correct answer. Okay, let's see the next question. Question number 11. The rate constant of a zero order reaction is 2 times 10 to the power minus 2 mole per liter per second. If the concentration of reactant after 25 seconds is 0.5 molar, what is the initial concentration? So we have given that the concentration of reactant after this much seconds will be 0.5 molar. We have to find out the initial concentration of the reactant, and the rate constant for the zero order reaction is given. So options are 0.5 molar, 1.25 molar, 12.5 molar, or 1 molar. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. So the correct answer is option D, that is 1 molar. So for zero order reaction, you know that the rate is equals to K, or dx by dt is equals to K. That is rate constant. And dx by dt, you can write it as x1 minus x2 divided by dt. Basically, it is x2 minus x1, but we write it as x1 minus x2 divided by dt. And K is given as 2 times 10 to the power minus 2, right? So, basically rate is minus dx by dt, right? So that minus we take inside, and it will become x1 minus x2 from x2 minus x1. And x1 we have to find out initial concentration. Final concentration we have given, that is 0.5 in the 25 seconds. So dt will be 25 seconds. It is equals to K. And when we solve this equation, okay, here it is written that x1 is initial concentration, and on solving this equation, we have x1 minus 0.5 is equals to 0.5. So x1 is equals to 0.5 plus 0.5, which is equals to 1 molar. Okay, thus the correct option is option D. Okay, let's move to the next question. Question number 12. The time for half-life period of a certain reaction A to the products is 1 hour. When the initial concentration of reactant A is 2 mole per liter, how much time does it take for its concentration to come from 0.5 to 0.25 mole per liter if it is a zero order reaction? Again, we have asked the time here, and the time which the reaction takes from going of the concentration of A from 0.5 to 0.25. Okay, options are 4 hour, 0.5 hour, 0.25 hour, or 1 hour. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option C, that is 0.25 R. For a zero order reaction, K naught is equals to A naught divided by 2T half. So basically, we just interchange some terms. T half or the half lifetime for the zero order reaction is equals to A naught divided by 2 K naught. Right? So if we write in the terms of K naught, it will be K naught is equals to A naught divided by 2T half. And since A naught is given as 2 molar, right, it is given that the initial concentration is 2 molar. So A naught initial concentration is 2 molar. T half is 1 hour because it is given the time for half life period of a certain reaction is 1 hour. So T half is 1 hour. Now we just put it here. So K naught will come out as 1 because A naught is 2. T half is 1. So 2 times 1 will be 2. 2 will 2 cancel out. So K naught will become equal to 1. And K naught is also equal to, okay, K naught is also equal to del of A concentration divided by del T. Right? Because it is a zero order reaction. So rate constant is equal to the rate. Right? And rate is equals to del of A divided by del of T. So, and directly it equal to K. Because for zero order reaction, the rate is equals to del A by del T is equals to K. And from this, we can equate the given values and K value, which we have find out. So del T, which we have to find out that how much time does it take. So del T will be equal to del A divided by K naught. K naught is 1, we just have count, and del A is change of concentration, so it is going from 0.5 to 0.25. So 0.5 minus 0.25, it is coming out as 0.25 R. Okay, so del T finally answer is 0.25 R, and thus C option is the correct answer. Okay. Let's move to the next question. Question number 13. For a first order reaction, the time required for 99.9% of reaction to take place is nearly. So a reaction is happening, and the time which is required for 99.9% of reaction happening will be. We have to find out the time. And the reaction is first order reaction. Options are 10 times that required for half of reaction, 100 times that required for half of reaction, 10 times that required for 1/4 of the reaction, or 20 times that required for half of the reaction. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option A, that is 10 times that required for half of the reaction. So K for the first order reaction rate constant is equals to 1 by T ln initial concentration, total concentration divided by the change in concentration. So total concentration is 100, and upon 100 minus 99.9, because we have to find out the time required for 99.9% of reaction to take place. Right? That means that the remaining percent will be 100 minus 99.9. Total percent is 100%. Total divided by remaining. So it will be 1 by T ln 100 upon 0.1, and K we can write out for the first order reaction as equal to ln2 divided by T half. Basically T half is ln2 by K. So you can write as K is equals to ln2 by T half for a first order reaction. So ln2 by T half is equals to 1 by T ln, and here it will come 10 to the power 3. Right? Now we just take the ln from log, so it will become log both sides. So log 2 upon t half is equals to 1 by t log 10 to the power 3. Yeah. And this term will become equal to 3 by t because log 10 is 1 and this 3 in the power with the use of log property come in the multiplication. So it will become 3 by t, and log 2 by t half is equals to 3 by t. So t half will be equal to log 2 upon 3 multiplied by t. Log 2 value is 0.30103 divided by 3 times t, and it will be coming out equal to 0.1 t. T half is coming out as 0.1 t, and we have to find out the time required for the 99.9% of reaction to take place. So t we have to find out. So t will be, this will go here, so it will be 10 t half. So t will be equal to 10 times t half. That means 10 times that required for half of the reaction, right? Thus A option is the correct answer. Okay, let's see the next question. Question number 14. A first order reaction is half completed in 45 minutes. So basically T half is given as 45 minutes. How long does it need for 99.9% of reaction to be completed? Options are 20 hour, 10 hour, 7 by half hour, 5 hour. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C, that is 7.5 hour. So for the first order reaction, the K is defined as 0.693 divided by T half minute inverse, because the time T half is given in minutes. So let's put it, so it will be 45. So K will be equal to 0.693 divided by 45 minute inverse. And for the first order reaction, K is also equals to 2.303 divided by time it will take for 99.9% of reaction to takes place log the total in concentration A divided by the change in the concentration, which is initial minus 0.999% of A, right? So T of 99.9% will coming out as 2.303 times 45 divided by 0.693 log 10 whole power 3. Right, so we just equate these two equations and find out the T of 99.9%, and it is coming out after solving this multiplication as 448 minutes, which is approximately equal to 7.5 hours. Okay, thus option C is the correct answer. Okay, let's move to the next question. Question number 15. For a first order reaction, A is going to products. The concentration of A changes from 0.1 molar to 0.025 molar in 40 minutes. The rate of reaction when the concentration of A is 0.01 molar is. So we have to find out this time the rate of the reaction when the concentration of A is given as 0.01 molar and the concentration of A is changing from 0.1 molar to 0.025 molar in the 40 minutes. This is also the information we have given. Options are 1.73 times 10 to the power minus 5 molar per minute, 3.47 times 10 to the power minus 4 molar per minute, 3.47 times 10 to the power minus 5 molar per minute, or 1.73 times 10 to the power minus 4 molar per minute. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B. So, by the first order kinetic, the rate constant will be equal to 2.303 divided by time log A upon A minus X. Initial upon change in the initial concentration. A is given as 0.1. It is changing to 0.025. So A minus X will be 0.025. And T is given as 40 minutes for this process, for this concentration change process. So let's put this value in this K equation. So K will become 2.303 divided by 40 log 0.1 m upon 0.025 m, right? And on solving this equation of K, we have K is equals to 0.0347 minute inverse. Now rate is also equal to dx by dt, right? And for the first order, it will be equal to x. It will be equal to K times concentration of A, right? So K we just have find out. So let's put it 0.0347, and we have given that when the concentration of A is 0.01 molar, the rate of reaction will be. So let's put the A concentration as 0.01 molar, multiply them, and the rate is coming out as 3.47 times 10 to the power minus 4 molar per minute. This is the rate of the reaction which is coming out. Thus, our option B, 3.47 times 10 to the power minus 4 molar per minute, is the correct answer. Okay. Thank you.